Please do respond in chat.
Yes, sir.
Okay, so in the previous class, we did this oxidation reaction and we saw how oxidation of alcohol took place. So
Yeah.
this is how we do oxidation. If you are going to oxidize primary alcohol with a mild oxidizing agent, then it will be converted into aldehyde. And then again, if you are going to oxidize aldehyde with that mild oxidizing agent, then it will be converted into carboxylic acid. So this is a mild oxidizing agent, RCH2OH, which is an alcohol. And if you are going to use CrO3, it is a mild oxidizing agent. So it will convert it into aldehyde. So basically primary alcohol converted into aldehyde. But if you have secondary alcohol, then it will be converted into ketone. So let's say I'm going to give you example on this. This is your CH3 and this is your CH double bond CH, and then it comes CH2 and then it is CH2OH alcohol, which is a primary alcohol. And if you are going to use either PCC or either CrO3, you can use. So it will be converted into, basically, as you can see, this is your primary alcohol. So this primary alcohol will be converted into aldehyde. Wait a minute, Firaz. Please do it. Yes, Firaz.
Yes, sir.
Okay, so this will be converted into CH2, and this CH2OH will be directly converted into CH. See this, what I wrote here is this PCC. PCC is basically pyridinium chlorochromate. Pyridinium chlorochromate. This is PCC. Okay, and this is a basically mild oxidizing agent. Okay, so as you can see, this is your primary alcohol. So primary alcohol will be directly converted into aldehyde. But when you are going to talk about the secondary alcohol, so this is RCHOH and R dash. And if you are using a mild oxidizing agent, so you can see what will happen here. It will be directly converted into ketone. So secondary alcohol will be oxidized. Secondary alcohol will be oxidized into ketone. It's very important to note. So the oxidation part is the way it is in the previous class, like what I told you. The alcohol is like this, right? And there will be hydrogen like this. So what you need to do, just remove hydrogen from here and remove one hydrogen from here. So removal of hydrogen is basically oxidation. So you will have this. Just remove this. So you will have this part, and now in order to stabilize itself, it will make double. So what you are going to do, remove hydrogen from here and hydrogen from here, and there will be double bond. In the same way, you can look at this also. Okay. So if I'm going to write this, you can see there is hydrogen, and the rest part on the left hand side, and there is OH. So what you are going to do, just remove this hydrogen and one of the hydrogen from this carbon. So there will be double bond between this carbon and oxygen and it becomes aldehyde. And in this case, it becomes ketone. So this primary alcohol will be converted into aldehyde and secondary alcohol will be converted into ketone. I think it's clear to you, right?
Yeah.
Okay, please do write it. Please do let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. So there are other ways to prepare or oxidize this alcohol, and in which we use basically copper. So it's very easy. And also there is very important point that we need to write. As you know that if you are having an alcohol which is tertiary, so you have this concept, you know, this hydrogen here it is available, but with this carbon there is no hydrogen. So that's why tertiary alcohol, are you getting my point? There is no hydrogen with this carbon. So
Yes.
tertiary
Oxidation
alcohol
not
do
possible.
not, yeah, do not undergo, very good, do not undergo oxidation reaction. If you are still trying with extreme condition, then the bond will be broken. Okay, then it is possible to oxidize. So it's a very important point. Now, the next point, which is very important, important reaction. If you are having primary or secondary alcohol in vapor phase, so I'm going to write 2 points. When the vapors of primary or secondary alcohol, primary or secondary alcohol are passed over heated copper at 573 Kelvin, then dehydrogenation takes place. Dehydrogenation, that means removal of hydrogen will take place. Dehydrogenation takes place. And an aldehyde or ketone formed while tertiary alcohols undergo dehydration. Dehydration, that means removal of water molecule will take place. So it's very easy. If you have primary alcohol and you are going to pass it through heated copper at 573 Kelvin, that means basically alcohol will be in vapor form. Then primary alcohol will be converted into aldehyde, secondary alcohol will be converted into ketone, and tertiary alcohol will be basically dehydrated. So we will see the reaction. First, you are going to write it and then let me know. Firaz, let me know when you are done with this. Firaz, are you done with this? Firaz.
Yeah.
Very good. Now see, so basically I'm going to show you the reaction. And you are going to pass it through heated copper at 573 Kelvin. So it will be directly into aldehyde. I already told you how the reaction will take place. So this and this part will be eliminated, and you can see this is RCH and O. So there will be double bond. In this way, primary alcohol converted into aldehyde, And if you are having the secondary alcohol, then copper at 573 Kelvin, you can see this hydrogen and this hydrogen will be eliminated and ketone will form. And if you are having tertiary alcohol like this, CH3, CH3 and CH3OH, then dehydration will take place. Copper at 573 Kelvin, then dehydration will take place. So as you can see, OH from here and H from any one of the carbon will be eliminated. So I'm going to write this CH3 and then there is C and this bottom CH3 on the right hand side. And I'm going to remove this OH and one hydrogen from here. So there will be double bond between this carbon and this carbon. So it will be converted into CH. Got it? So whenever there will be tertiary alcohol, then dehydration will take place. Dehydration, that means one water molecule will be eliminated or removed. If you still have any doubt, please ask. Please do let me know when you are finished with this. Are you done with this, Firaz?
Yes, sir.
Now the next topic is basically reaction of phenols. We are already we are done with the reaction of alcohols. Now we are going to start reaction of phenols, and after this we will start ether. So reaction of phenols, it's very easy. So the first topic is electrophilic substitution reaction. Electrophilic aromatic substitution. Aromatic substitution. Electrophilic aromatic substitution. Now see, this is the reaction of phenols, electrophilic aromatic substitution. So there will be electrophilic attack on phenols. So the first in this is the nitrase. Nitration will take place. That means nitro group will be adding in this. So if you are having an alcohol and if you want to add NO2 in this phenol, if you are having a phenol, so you need to pass this through or react with dilute HNO3. There will be two places that NO2 will attack. The first one is basically you can take ortho, and after ortho it will attack on para, NO2. Now see, it's very easy to understand. Can you tell me which one is major and which one is minor? So this is your major product O nitrophenol and this is your P nitrophenol, which is para. One of the most important point is that this there will be fractional distillation. This can be separated with a method that is called fractional distillation because their boiling points difference. There is a difference in their boiling points. There will be intermolecular hydrogen bonding and there will be intramolecular hydrogen bonding. So due to this having intermolecular hydrogen bonding, the boiling point of this will be more than this. So we can easily separate it with the help of fractional distillation. I think you know steam distillation or fractional distillation. Do you know what is distillation? Yes. Yeah. So I'm going to write a point about this. Please do write with me. The ortho and para. Isomers can be separated by steam distillation. Wait a minute, it's not working. Steam distillation. Ortho nitrophenol is steam volatile. Due to intramolecular hydrogen bonding. I'll show you the hydrogen bonding. Intramolecular hydrogen. So I think you know what is intramolecular hydrogen bonding and what is intermolecular hydrogen. Are you aware of this? Yes or no?
Yeah, intermolecular means like bond between the same compound.
And what is intra?
Intra would be like bond between another different compound. Like, for example, if you're diluting
within the intra is within the molecule and inter is between two molecules. Are you getting my point?
So yeah, that's what I said actually.
Yeah. Got it. While P nitrophenol is less volatile due to intermolecular hydrogen, which causes association of molecules. Please do write it. And then let me know. I'll show you the structure and you will get. Let me know when you are done with this. Are you done with this? Firaz? Are you done with this?
Yeah.
No. So see, I'm going to show you the this what we call intermolecular and intramolecular hydrogen bonding. So on ortho position, as you can see, this is your ortho position. This is benzene, and this is I'm going to show you like this O and double bond O. And with respect to OH, we will see with respect to OH, NO2 is on ortho. And if you don't understand it, let me just make it clear in the same way. So this is your OH and this is your N double bond N and this is your O. So there will be hydrogen bonding between these two in the same molecule. This is your basically intramolecular hydrogen. Intramolecular hydrogen. And if you are going to look at the para position, so you will see this is your OH, and I'm going to show you this is your N double bond O, and this is your O, and again there is another molecule of para. So there will be hydrogen bonding between these two, and with the help of this hydrogen bonding, it becomes one molecule. Two molecule of para-nitrophenol will be one molecule of this compound. So it associates two molecule becomes one molecule. That's why due to molecular weight increasing, the force of attraction also increases, and in this way it is more stable and less steam volatile. Is that clear? Firaz? Please do it and let me know when you are done with this. Let me know when you are done with this. Are you done with this, Firaz?
Yes. Yes.
Okay. Now see, we use dilute HNO3 in phenol. But if you are going to use concentrated HNO3 in phenol, then you will get citric acid. Concentrated HNO3. Then you will get this. This is your OH and NO2 at second position, NO2 as fourth position, and NO2 at sixth position. So IUPAC name will be 2,4,6 trinitrophenol, and its common name, which is quite famous, is picric acid. Picric acid. Is that clear?
Yeah.
No. There are other ways to prepare picric acid. So go through NCERT as well. Okay. You can prepare with the help of phenol and concentrated H2SO. Okay. It will be converting it into 2,4 disulfonic acid and then again treating it with HNO3 that will convert it into 2,4,6 trinitrophenol. I'm going to write it. You can write the reaction. Nowadays, picric acid is prepared with phenol. First treatment with concentrated HNO3, and it will give you on phenol concentrated HNO3 converted to phenol 2,4 disulfonic acid. Phenol 2,4 disulfonic acid, which converts using concentrated nitric acid, which convert it into picric acid. So this is how nowadays, no, wait a minute. This is your H2SO. If you are going to use phenol with concentrated H2SO4, this is what you will get. Phenol 2,4 disulfonic acid. Can you write the structure of this? Firaz?
Yeah.
No. Please do write it.
It's just SO3.
Yeah, this
HSO3,
is
right?
phenol you're going to write.
And 2 and 4 position.
Yeah, SO3H. Yeah.
Yeah, SO3H.
This is how. Please do that. Let me know when you are done with this, please. In the next class, most probably we will complete this start. Okay. Firaz, are you done with this?
Yeah.
Very good. Now, the next is basically halogenation. Halogenation, that means you are going to add halogen in phenol. So as you can see, this is your phenol. And in order to add halogen, so this will be your Br2 in carbon disulfide at 273 Kelvin. That means cold, 0 degree centigrade. So bromine will be added at ortho with respect to H. You can see or bromine will be added. The another product will be para. So this will be your major product and this will be your minor product. But if you are going to use 3Br2 or bromine water, you can say with OH. phenol, if you are going to use 3Br2 or bromine water, then you will be getting 2,4,6 tribromophenol. This is your Br, this is your Br, as well as this is your Br, and 3HBr as a byproduct. So what's its name? Its name is 2,4,6 tribromophenol. Tribromophenol. Please do write. Please do let me know when you are done with this. Firaz, are you done with this?
Yeah.
Okay. So do you write slow, or my screen looks slow? Or when I write it, it goes slow? Firaz?
Yes, sir.
Always reaction. So see, this always reaction is basically your name reaction. So how Kolbe reaction takes place? Basically, there will be reaction of phenol with sodium hydroxide. Then we will get phenoxide ion. Then we will get phenoxide ion. So I am going to write phenol treated with sodium hydroxide. And then phenoxide ion is formed, which is more reactive than this phenoxide ion is formed and is even more reactive than phenol, even more reactive than phenol. Now see, after forming phenoxide ion, you are going to react this phenoxide ion with carbon dioxide in the presence of H plus, then you will get salicylic acid. So this is what I'm going to write. Phenol towards electrophilic, aromatic substitutes. Electrophilic aromatic substitutes. And this phenoxide ion is going to treat with, just let me write, then I'll explain. It undergoes or it react with basically phenoxide ion. Phenoxide ion reacts with carbon dioxide in the presence of H plus. In the presence of H plus. And then orthohydroxy, O-hydroxy, benzoic acid is formed. This reaction is known as basically Kolbe's reaction. Please do write it, then I will write the reaction. Now, are you done with this?
Yes, sir.
Very good. Now see the reaction. First, you are having phenol that you are going to react it with sodium hydroxide, that is NaOH, and then it will give you phenoxide ion. This is ONA, phenoxide. After getting this ONA, you are going to react this with carbon dioxide in the presence of H plus, and you will be getting, there is OH and there is C double H. Since carboxylic acid is, we give preference to carboxylic acid more, so this is your ortho position. So this is 2-hydroxy, we can write the name 2-hydroxy benzoic acid. Benzoic acid, or we can write its common name salicylic acid. Is that clear? Please do write it and let me know. Then I'm going to give you a question. We will discuss it today. It's not test. Give us structures. Give us structures of, give us structures of the products you would expect when each of the following alcohols reacts with A. First, you are going to react it with HCl, ZnCl2. Then that alcohol should be reacted. What is the product? You need to tell me. And for B, it is HBr. You need to react that alcohol. And for C, you need to react with SOCl. SOCl. Okay. Are you done with this always reaction? Yes or no? Firaz, are you done with this always?
Yeah.
Okay, so please do write the question, and if you don't understand the question, please let me know. I'll explain it. First, you are going to react this butane 1-ol with ZnCl2 and see the product. Then butane 1-ol with HBr, then butane 1-ol with SOCl. So there will be 3 reactions in this, and then we are going. You are going to react this another alcohol 2-methyl butane 2-methyl butane 2. This is your question number 1, and this is your question number 2. Predict the major product Predict the major product of acid catalyzed dehydration of first one is 1-methyl cyclohexanol, and the second one is butane 1-ol. Please do write it. Are you done with the first question? Have you
No,
written
sir.
the first question?
Should I send these answers?
No, don't send it. Are you have you completed with answer, or you are just writing the question, right?
Yeah, I'm writing the question.
Okay. Please complete the question, then we will discuss it after completing. Okay. You will first give an attempt to this, and then we will discuss. Write the structures. Wait a minute, it's hanging. Firaz, am I audible? Please send this in PDF form. Let me know when you are done with this.
Done, sir.
Okay, please do solve it. Okay.
Yeah. So today, 1 hour class.
Firaz, did you say anything?
Today is 1 hour class.
You are not audible.
Is it 1 hour class?
Mononitration of phenyl methanoate.
No, no, I asked if 1 hour.
Which one you are talking about? Your voice is so low.
So these answers are done.
Are you done with all the questions?
Yeah.
Okay. So just wait for a few minutes. I'm just discussing. Can you send me the answer in chat box? Just write the answer. Butane one all is this the answer for the first question? Very good. With VR, it will form. Predict the major product of acid catalyzed. What is the major product on acid catalyzed of this? 1-methyl cyclohexanol. Now you can tell me directly.
Methyl cyclohexane. Methyl cyclohexane.
Methyl cyclohexane, right? Yes, methyl cyclohexane. And what about the second one? It is butene, right? Butane one all will be converted into butene. Yes or no?
Butene, right?
Let's see, this is your where it is butane one all. So this is your CH3, CH2, CH2, and then CH2. So OH will be removed from here and hydrogen from here. The double bond will be in between this now. One product will be there.
Okay.
What about this monofluoro? Have you completed this? Mononitration of 3-methyl phenol. It's very easy. 3-methyl phenol. So you are going to write this OH and this is your methyl, and you are going to do monochlorination, which should be measure. Measure is basically para. So this will be the product. Dinitration of 3-methyl phenol. So 3-methyl phenol. First you are going to write the reactant this, and in order to add 2-methyl group here, it's very easy. There will be 2 products. First one is this ortho, and second one is basically this is para. This is para, and second one is second one will be ortho. So this will be your ortho. Now see, this is your you are going to do the dibromo. So it will be NO2 here and NO2 here. And for mononitration of phenyl methanoid, first you are going to write the structure of phenyl methanoid. So it will be like this. This is your phenyl and methanoid OCOCH3. So mononitration, the major product will be at para. Is that clear?
Yes.
So this is how you write. So did you completed this? Did you complete this? Yes or no?
Yes.
Can I change this slide?
Yes, sir.
Now see, we have basically the Riemer-Tiemann reaction. Riemer-Tiemann reaction. And this is a very famous name reaction, which is very important. So in Riemer-Tiemann reaction, we are going to react this phenol with chloroform in aqueous NaOH sodium hydroxide. Then we will get an intermediate, that is basically phenoxide type O negative Na plus, as well as there will be CHCl. And after getting this intermediate, we are going to react this with again this sodium hydroxide. Then you will be getting the CHCl2 will be converted into aldehyde, and the rest part will be as it is. And then after getting this, you are going to react this with H plus, and this H plus will replace Na plus, and you will be getting this OH and CH. And you already know this compound from this chapter, which is salicylic aldehyde. Salicyl aldehyde. So this is basically your Riemer-Tiemann reaction. Yeah, this is intermediate. Please do write it. Are you done with this? Firaz, please do let me know when you are done with this.
Done, sir.
Very good. Now see reaction with zinc, in which phenol will be converted to benzene. Reaction of phenol with zinc dust, or you can write zinc. So when you are going to react this phenol with zinc. This zinc will reduce this phenol and it will be converted into benzene. Now the fifth and the last reaction of phenol is oxidation. And when oxidation of phenol takes place in the presence of Na2Cr2O7, it will be converted into benzoquinone. So this is your basically phenol, and you are going to react this with Na2Cr2O7 in the presence of H2SO4. So it will be directly oxidized like this, and this compound is known as benzoquinone. Please do write it and let me know.